Hi everyone, I'm going to try and do this video in two parts just because I think, well, let's go back a bunch, just because I want to see if I can get more videos out of the way and get them available to you guys earlier rather than later. So, you notice this is the same outfit I was wearing on the first day of class because that's when I'm recording this. So I want to go over collecting and cleaning data. There's a bit of this talk that's going to be synchronized, so that's hence the little comment in here. But maybe the sub bullet point here is the more important part of this whole process. Maybe I take too much glee in pointing this out, but I love the fact that when you can point out that no matter who you are, no matter where you get your data from, no matter what the circumstances are, your data is always garbage. Like there's always something to fix in it. It's never 100% perfect, or I've never encountered a case where your data wasn't 100% perfect. There's always some form of transformation, some kind of cleanup, some kind of analysis you need to do. It is a large chunk of the time that you spend when dealing with data. Unfortunately, it also is something that there is no one size or one stop shopping way of cleaning your data. It's actually a lot more convoluted than you might think. It requires a lot of judgment calls along the way. We're going to talk about the higher level view of how we can analyze or look at the data, but the actual policies, the actual things you'll have to do for your projects are up to you guys and your projects, whether you find error sources from this or that or something else. So depending on your data, you may have an error source due to reporting errors. You may have it oversampling or overfitting your data. You may have error sources in terms of having to transform log data into more quantitative data, things like that. And so I like to point out the fact that most of you, I don't want to actually know where you get your data sources from, but let's think about it for a second. Why do you trust the data or your news source that you have? What is it about your particular place where you get your news that you trust, or why is it that you think it is a quality journalism? I would say that we're hearing a whole bunch of different things. I love using COVID as examples just because it's right in our face all the time. And where at one second you might read an article where COVID is the worst thing ever, and then other times you'll hear something from the Trump campaign and it's downplaying COVID, or how lethal it is. Russia seems to have they had a vaccine. They don't actually they didn't actually test it, but they have a vaccine. China has 6 cases of COVID per day in a country of 1 billion people. Where do you trust, who do you trust, and how much do you trust a given news story? And that's open. It's open for debate. I got a kick out of the fact I went for a walk this summer with my boys, and I met this nice woman, talked to her, pet her dog, and we were talking about COVID, of course, because that's what you do. And I mentioned something about the leading cause of death in Russia being pushed out a window rather than COVID, because I make jokes when I'm uncomfortable. And she immediately started getting all tense and, standoffish, and was very, very clear that why should I distrust the Russian media and Russian news? Why do I trust American news or Canadian news as opposed to Russian news? And that got me thinking, because I first of all, I do not actually trust the Russian news agencies. That's just maybe a bias on my part, but people being pushed out the windows, that's a dead giveaway that there's something really wrong going on there. Also, their COVID curve is almost a perfectly flat. It's cleaner than any other country on the planet. But that's not to say that Canadian and American news is also not extremely biased, or have a particular axe to grind, or a particular insertion on what is correct. And so, how do you identify incorrect data? So let's see if I can do a quick view of this here. It's overfitting data. Coronavirus map. Okay, so here is world coronavirus map. Here is we'll get the U.S. All 6 million people that have either had coronavirus or still have it. If we look at how the trends go over time, you'll see a nice little bar graph here. Kind of noisy bar graph. India ramping up, but it's fairly noisy. Brazil, really, really noisy. Russia, perfectly smooth on the downward slope here. Look at this, perfectly smooth. Peru, everywhere else you have a nice spiky pattern, except for that. Iran is all over the. It's a bit smoother, but it's still pretty much all over the place. United Kingdom, spiky all over the place. And then let's go further. Where we're at 140. Jeez. And then China with 1 billion people. There you go. The question is, this is one country with 1 billion people, the one country in the entire planet that does not have any coronavirus cases, hardly at all, in God knows how many months. Yeah. So the question I have is, how do you know what to trust? How do you know what you need to clean? How do you know whether you have sources of error? How do you identify things? Because you were presumably trying to represent data in the best way possible. And so my argument to you would be, we would need to at least be able to identify sources of error and how we could clean our data. So I also like the fact that it used to be worse way back in the day, back in the bad old days, before we had to Google family plans and stuff like that. So my kids would be looking up all sorts of weird things about Pokemon or Transformers or Legend of Zelda and all this kind of stuff. And it would all be on one Google account. So what do I get? I get all sorts of ads on Pokemon and Transformers and because the data that their algorithm is getting is from my kids. They don't know it's from my kids, and I'm getting the wrong recommendations as a result. How do you know if the data is clean? There are life circumstances all over the place. We have all sorts of life circumstances that will throw off our data. And how much tolerance you have for esoteric one-off things or frequent things, or maybe you were just curious one time to find out what, about, let me think of a good example, what the term Byzantine means. That's the example I'm giving here. I wanted to find out what the actual term meant because it gets thrown around a lot. What does it actually mean? Am I obsessed with the Byzantine Empire? No, I am not. But it was a search term I used one time this summer just to find out more about why the term Byzantine comes up. It means overly complicated and bureaucratic, by the way. Right? But should they be putting lots of examples of this? Now you could say, well, don't ever put something with one instance. Sometimes I do want repeat stories based on the one search I did one time. You don't know necessarily. Even if I did multiple searches on that particular topic, I may want it, I may not want it anymore because I purchased something. You could finally get a machine learning algorithm to finally get closer to what our interests are, but it's still a lot harder than you might think. So the question is, how do we know when the data is garbage? How do we know when it's clean? So let's just go back to the full screen mode. So we have a bunch of different ways of collecting data. Now, this is not just this. There's probably lots and lots more than this. But these are the ones I could just come up with the top of my head. So one of the big ones for me, and probably for your projects, log data, right? You just record what people do with your system, or when something happens. You store it into, just say, a text file or into a database, and then you can go and access that data later. It's like game event data as well. You can also do survey data. I'm doing that to you guys all the time. That's what homework 1 was. I gave you a survey. What do you think of this course? What do you know? What's your background? What languages do you program in? It's still data. It's a different thing. One is implicit. I do stuff and I'm logging it. This one is explicit. I'm telling you something. I can merge multiple scraped data sources together. It is not one data source. It is actually inferential based off of merging multiple different data sources together. And if they are not properly, they don't map up exactly right, you're going to have incorrect data. You can get sensor data. Again, it's implicit, but it's essentially log data, but only for sensors. People are not doing anything, just a sensor. It might be some external database that you have access to. It might be your personal database. It might be a spreadsheet. There are a slew. Could be JSON files. There are a slew of different things, both quantitative, meaning numbers, and qualitative, meaning text, words, interviews, that sort of thing. So when I do interviews with people, I will collect transcripts of everything someone says to me when they're talking about some interface, and I am analyzing what words they're saying, not in terms of word frequency, but in terms of patterns and topics and themes of what people are saying about, let's say, a particular interface or a particular topic. That's qualitative data. You cannot do statistical analysis on qualitative data. You have to do other forms of analysis. Quantitative data is our numbers, what most of us are familiar with and also more comfortable with. Here is what we did earlier on. By the way, I was wrong in class today, which is why I'm bringing this up. It's extract, not export. Extract, transform, and load. It is the idea that you have all these messages from, let's say, a game server, passing these messages off. They need to be processed correctly, to be stored correctly so they can use the data. So extracting out the useful information, transforming it into something meaningful or the right format, and then loading, and then sometimes I might need to load the file. The idea is it's just transforming big, bulky, maybe overly robust, overly verbose data into something more meaningful, more useful for later analysis. This is the kind of thing that you'll see over and over and over again, some kind of process in which we can convert data. That's transformation is one of our main things that we do for cleaning our data. It's sometimes not so obvious. If it's not something that you can formulaically or programmatically transform, then that transformation is on a case-by-case basis and done by hand, and it's a pain. But sometimes it's necessary, because what you don't want is all the log data from the game server just stored in a database, and then you have to extract out the meaningful bits of information from that when you're analyzing what players are doing. What I really want is a bunch of numbers, and I want the numbers on the particular topics that I want, not the full text message that they sent to their friend while playing the game. So we are going to do an in-class exercise. You're going to look at this. It's a relatively short article about data science for a startup data pipeline and what kind of data you have, whether it's raw, processed, or cooked. What do you like about the paper, or what do you like about the article? What do you dislike? It's one person's opinion, but I thought it was fairly informative. We'll also, when we're looking at this, he was talking about the fact that the data pipeline has changed over the years for the game industry. And so we went from flat files to databases to data lakes to serverless, and we're going to talk about that in a bit more detail in the synchronous class. And then how would we, I'm not sure if we're going to do that part. So sometimes I need to get that data to a database, and there's a bunch of different ways one can do it, including taking a JSON file, which is an XML file. In case you don't know what a JSON file is, it's an XML file, a particular format of XML. So it's a marked up file that has a particular format that allows you to indicate information about classes and objects from code, essentially. Classes and objects, so you can pass in essentially a text file and generate program objects. It's extremely useful if you're dealing with a lot of, if you're trying to send things from client to server, that sort of thing, because you may need to reproduce the code on one end on the other side of the line, the other side of the wire. So you send a JSON file from the server to the client to reproduce what was on the server on the client side, on another computer, essentially. In terms of data that we're looking at, we might have windowed or batch data. So batch data meaning you build up a bunch of pieces of data before you send it off. Windowed data would be, it is a slice of time, and then you move that slice of time. So, or you're talking about particular, you have moving windows, I guess, or a window is in, this is the data for this timestamp to this timestamp. And then the next window is from that same, the end timestamp to the next one. And then the next window is from here to here, and then from here to here. There's ETL, right, where we talked about extract, transform, and load, where we take log files and then it gets processed. It's another step to process the data, make in the better format, and then use it. And then we can just have raw data if we want to send that to a database. That is, I send in like a comma separated value file or a CSV file, and I have to process that just flat file essentially, or maybe it's not, maybe it's just actually raw data, and I need to process it before I can send it to a database. But ultimately, I just want to save most of the time I want to just save information into a database because I know it's secure. You don't have weird duplication in your code. Ideally, it's you don't have run race conditions when it comes to extracting versus modifying the data. You have it's sort of meant to minimize the amount of data stored while maximizing the utility without necessarily having, so avoiding duplication of your code and not having to worry about which order and the timing of events. That's what databases are really for. Storing large amounts of data safely so that you can access them. And we'll look at that soon. You can have a quick break and have pause the video and read. I'm not going to read this out to you, but I find it funny as heck. If you don't know what this is all talking about, sanitizing your data, if you're putting information into a database, just raw, let's say, like what we were talking about here, just raw data going in, then you can always put in something that is malicious. It is the expectation you should have if you let the public send information your way directly without you processing and cleaning it. And so if you pass in unsanitized data, what you can have is, here is an instruction, your son is Robert / semicolon drop table students, right? It is going into and calling, it's trying to drop all the tables, all the data for all the students at the university with this escape command. There are malicious ways to hack information by sending in raw text, and if you're not checking and confirming that someone's not trying to do that, people will be trying to do that to your data. And this is just one of those fun little examples. So again, I really have to find out the original source of that quote here, but 80% of your time is cleaning and transposing data. This is a huge chunk of the time. Sometimes, even with the best intentions, you may have recorded, save that data in a particular format for a particular reason, and then you need it in a different context and you need to do the transformation. So sometimes you can use the data as it is. Sometimes you want to transform it. If you might be aware, I tend to be a bit verbose, even in my log data. So my log data will have pertinent information about what the fields are versus just the minimum size of all the data. The reason I would put that in there is just because if I accidentally have a bug somewhere in my code, I need to be able to trace down what each of these fields are, or if I have something wrong. Well, if that's the case, I need to strip out all of this extra information, like the field names on every single field. I want to have the minimum data set. And so a transformation is necessary in that case. There's all sorts of reasons you might need to clean or transpose your data. But the accuracy, the cleanliness, and the correctness all change what you would expect. So there's also whether you can infer something about your data. Inferential data, meaning if you give me I have a bunch of data, categorized data. So it is a bunch of photos that I say are pictures of me, let's say. If you send in a new photo, can you infer that is a picture of me or not? So the ground truth data would be stuff that I know to be pictures of me. Someone said it's a picture of me. Or that's also training data, I guess. But versus inferential data is, I'm inferring that this photo is a picture of me, but you don't know for sure. No one's officially said it. You're just inferring it based off of the patterns that you've seen in the data. And if ground truth data is incorrect, it ultimately means your inferential data can also be incorrect because it's based off of what you know to be true. And if what you know to be true is wrong, it throws everything off. There's a great Wikipedia article if you want to have a look at it for data cleansing. There's lots to talk about, but we're just going over the high-level view of things. So again, non-exhaustive, but where can we get data errors? Well, a lot of these come up in multiple different fields. So sampling errors, for example. response bias. We're about to do a U.S. election right now, so this would be one of those great examples. How do you find out what the average American thinks about politics in the U.S.? Well, how do you do it? Do you phone people? Who do you phone? Do you phone their landlines? Okay, well, if you're phoning landlines, you're not getting a chunk of people that only have a cell phone. And when you do talk to somebody, who are you talking to? You're talking to the people that have enough time to answer your question about politics. Not really busy people, not people that can't afford to pay their phone bill, not a lot of other people. You're getting a non-representative sample of the American populace, and you have to work really hard to compensate for that. You may also get outliers. You have one person that's really, really, really angry or really, really, really motivated one way or the other, and they throw everything else off. I get that with students, where you get one person that really hates your class and everyone else is okay with it. But that one person that really hates your class throws all the other data off. They're an outlier. Or someone that's particularly slow versus everyone that's particularly fast. Or someone that really doesn't get, lucked into university when everyone else, earned the position, but some person just got lucky and got in, or had a really easy high school and they're an outlier compared to everyone else. We also have user biases. I mean, the Hawthorne effect is one of my personal favorite ones. This is, anytime I hear the word Hawthorne, I think of this effect. It's a town in a bunch of different states, but I think it's a town in New York for this particular effect. The Hawthorne effect is this. They were trying to see, in a factory, a bunch of factory workers, they were trying to see if the conditions for the factory changed how productive workers were being. Simple enough. So they're asking workers to make these little widgets. Okay, that's what they do in this factory. And then they're changing the conditions. And so they play a little bit of music, let's say, and the workers worked a bit better. And then they try this. They increase the lighting, and the workers work a bit faster. And they try this, and they try that. And they keep on going back to the normal way of, making these widgets. And then they change the conditions. And every single time they changed the conditions, the workers got better. Including when they started turning down the lights and when they turned the lights completely off. The Hawthorne effect is one of those cautionary tales. It's shorthand in psychology and for a lot of other fields. It's shorthand for careful if the user knows what you're doing or what you're testing. The Hawthorne effect means that when a user thinks they're being evaluated, they are going to be good little users, and they will actually increase their productivity trying to be good. They're not trying to be malicious. They're not trying to screw up your experiment. They're thinking they're being observed now, so they're going to be on their best behavior, and they work harder. But which means that if someone can tell the difference between your condition or your system and the old default system, if they know what the question is, if they know you're trying to evaluate one thing or another, they will be good to you, unfortunately, and try harder when they think it's the experimental condition. So if I have a system A that I just worked really hard at, and I was trying to do a great job, and then I'm comparing it against, let's say, so I make a new social media website like Facebook. I call it My Book for My Face. So My Face, it's a brand new system, looks almost like Facebook, because I'm going to copy them. So I compare some user trying out My Face to Facebook. And lo and behold, everyone loves My Face more than Facebook. Why? Because they know Facebook. They know that that's the control condition. They're trying to be nice. They'll say how much they love My Face, not Facebook. Just because they're going to be good. It's the polite thing to do, if you will. That's the Hawthorne effect. Users will bias your experiment even for the best of intentions. It is something to look out for. Mechanical Turk, same thing. If they know what the experimental condition is, they'll just twist things around a little bit. Interesting thing about that is if you give them enough or you monitor them enough, if you put a camera in front of them, people will act well until they get tired, essentially, or stop worrying about the camera, and then they'll go right back to what they were doing before. It's like a diet. And so one of the workarounds for the Hawthorne effect is just keep on giving them conditions until they stop worrying about the conditions. Or hide the fact that when you're on different conditions. You can have experimenter or data collector bias. This is why you do, I have a bit of redundancy here, double-blind experiments compensate for both of these. If the person being tested doesn't know what the conditions are or what's going on, and the person who's giving the test doesn't know what the conditions are, then you can avoid a lot of these biases. You also have things like data format issues, right? If the data is in the wrong format, so you don't have the precision that you need for your data, for example, and it cuts off after a certain amount of time, or you round all your data points and suddenly throws off all your data. These all can come into effect. Or maybe that you're taking in text strings and the strings that you reserve are not big enough. This is more of a user issue than it's a source of error, but it's not in the data itself. Correlation and causation. If you do not know this difference, please learn it very quickly. If you have a correlation between two things, spurious correlations, I think is the website. You can check it out. There's correlation versus causation. You'll see lots and lots of websites. For example, global warming, pirates prevent global warming. Okay, there's a correlation between the drop in piracy and the increase in global warming. Therefore, pirates prevent global warming. That's just science, right? So correlation, just because you have a correlation does not mean you have a causation. There could be a third factor that's influencing it, or it could just be, somewhat coincidental. And so I want to be very clear that if you start making causality implications in your system and you only have a correlation, you're gonna get some dirty looks from me. You can also have, by the way, data corruption. I've loved this it's a Radiolab podcast. I love it. Maybe it's biased. It's one of those weird, quirky things that if you can look into. It turns out that storing things on using, electronics, it's biased and it's easy to break. So it turns out that even cosmic rays can actually flip bits in computer storage. It actually happens. It's so rare that you don't even notice it most of the time, but it can happen. And so they recorded cases of, for example, certain people when they were doing an election in Belgium, the numbers for one candidate was like a fringe candidate got something like 64,000 extra votes than they were supposed to. Because of 64,000, or it wouldn't be 64,000, but it's one of those powers of 2 up there in about 64,000 range. One of those bits got flipped, and they don't know how, but it got flipped, and so suddenly the vote count for that one person is completely off. And so if you don't have redundant data, this can happen. And that's why planes have a lot of redundancy in their systems nowadays, because of bit flips. They actually happen more frequently when you go up in a plane. And so you get also corrupt data, which is data corruption is similar to corrupt data. It's just a very specific version of it. If you have other sources of error, I'm sure there's lots of other sources of errors. Please let me know. I would love to find out either in a comment or we can talk about it in the synchronous class. But the point is, you can't assume either the data being collected is being collected correctly, that the data itself is not being corrupted in some way, or that you're not extracting the inferences you're making about the data are not incorrect as well. And that's a big issue. I'll pause the video after this, after we talk about some error types. So one is an error of omission, right? If you leave off a particular data point, or you leave, so I asked you guys to take survey data. If somebody does not fill in the survey data, that is an omission, right? That person did not submit something. So if I'm trying to make inferences about the entire class, that actually is biasing what kind of inferences I can make about the class and what they know. That person could be just like everyone else, or they might be way off from everyone else. We also have accuracy. Accuracy and precision is something that people always screw up, so I like pointing it out. Accuracy is how close to the actual target you are. So it is if you are approximating or coming close to what the true target is, or what the truth is. So it is, let me think of a good accurate thing. It's always hard to come up with something on the spot when it comes to that. It's somewhat of an accurate statement, actually. Accuracy is when you're getting close to the target. You may not be dead on, but at the same time, all of your things, all your data points, let's say, are approximately around the target. Precision is the conclusions you make are very tightly bound together. So all of these things give the same kind of result. So I measure these photos, I get the same result. So I take a photo with my phone, with my Google phone. Every time I take a photo of some plants out the front, it says it's oregano. That's very precise. It may not be accurate. The plants I might be photographing might be different. They may not be oregano. If I take a bunch of photos, and a lot of the time it's around oregano, it might be some kind of oregano, it might be a plant related to oregano, that's accurate. Versus precise is it's always saying oregano, but it's actually not oregano. It may not be oregano at all. You want accurate and precise, but that can be hard to do. Overfitting your data. This green line here is an overfitting of the data, right? When you have you put a whole lot of data and you try and fit the data more than it actually warrants. There's always a certain amount of noise in your data. And if you try and overfit it, you get an incorrect, overly complicated, if you will, conclusion about your data, when it's actually just the random noise that's causing this particular problem. How fresh your data is. So when I'm doing searches, if I on Google, for example, if I'm looking for a car, when I buy my car, I don't want any more suggestions on what to buy for a car anymore. The data is no longer fresh. So all those conclusions we had about, this person's in the market for a car is no longer accurate anymore. As time goes on, the accuracy of your data is going to shift because it's no longer, time has passed. You can also make logical assumptions or logical conclusions about your data that are incorrect. And then you can also have duplicate data. And that duplicate data can actually throw off your numbers, because if you have duplications, you are going to count that what should be one data item twice, right? If each of you submit the same homework, or a couple of you submit the same homework or the same survey twice, and I record all their survey answers, when I figure out what the average number of hours you work per week are, that person that submitted the survey twice is going to throw off our numbers. So these are the kinds of errors that we can get. Okay, when we come back next time, we're going to look at data validity, and then we're going to, then we'll probably stop after that. All right, thanks everyone.